Welcome to our module on memory forensics for threat detection and incident response in modern investigations. My name is Chip Thornsberg, and I am Associate Professor of Cyber Defense at Northeast Lakeview College. I actually am the program coordinator for that. I'm still a Texas Master Peace Officer and Electronic Crimes Investigator. I conduct digital forensics examinations and cybercrime investigations. Still a member and subject matter expert for the Secret Service Electronic Crime Task Force. More than 15 years teaching college level courses in forensics and cybersecurity, 30 years of cybersecurity, IT, and investigative experience. Author of the book Intrusion Detection and an introductory guide. And I presented on memory forensics, threat hunting, network analysis, cyber investigations at regional and national conferences for a number of years now. So at least 10 years. So our objectives for this module, we're going to talk about how memory functions in the device. We're going to talk about memory forensics acquisition and analysis tools. We're going to describe the common behaviors of malware. That's very important for developing a investigative methodology that involves memory forensics. And then the second part of this, we'll actually conduct a memory analysis using Volatility 3. And so this should give you a good overview and introduction to that. Device memory, if we think about a computer system, we would say a computer takes input, does some sort of processing with a CPU, and provides output. That's like the basis of a very simplistic explanation of a computer system. And so memory fits in kind of two parts. So as data goes into our input devices, either read from storage or from a keyboard input or from uh, a camera system, whatever input comes through, it passes through memory. It's fed into the CPU where the processing happens. The CPU pushes it back out into memory where it's held, and then it goes through its output. Either it gets stored or it gets printed or it's displayed on the screen. And so we can think, if we think that through, every bit of information in a computer system is going to pass through the device memory at some point. And this is really important because when data is going into the CPU for its processing, it's not encrypted at that point. You can't send encrypted data into the CPU for processing. So even if you have encrypted content within a system, there are points during that system, during the process, that the data is unencrypted, and that is essentially held in the memory of the device. Memory is considered volatile. And so we say volatile, it is subject to being overwritten or being lost. So we should know at this point in our studies, right, if power is lost to the computer system, the information being held in memory, much of that is being lost. The running joke, right? Have you tried restarting the computer, right? Often we do that in order to clear corrupted elements out of the memory, right? It gives the system a fresh start to go through. So things that are being held in running memory, though, all the running processes, so every program that's running, all of its associated, its handles, right? Every DLL, every configuration, all of that's being held in memory. The network connection information and the data, oftentimes, is being held in memory. Encryption keys, so that's password, that's your Bitcoin passphrase, that's the BitLocker encryption key. Those things are being held in memory because the system uses those to decrypt on the fly as needed, or encrypt if it's going to store it back on the device. Clipboard contents, unsaved user data, think on and mobile devices, so text messages, pictures on a computer system, working copies of every document that's brought up and read, copies of web pages, right? All of that is being held or cached inside of memory, which means with the right tools, we can access it. And so there are a few memory acquisition tools that are out there, a free, so open source free, big fan of that. Access Data's the Forensics Toolkit, FTK, has memory capture capability. You can capture the memory, you can capture the page files, which is essentially where when memory is filling up, the system will write contents back into the hard drive to save space or to free up space in the memory. And then crash dump. So when Windows systems crash, and we see the familiar, that blue screen of death, what's happening is all the information that was being held in memory, it's writing that down to the hard drive. And we can analyze that. It's not stored nicely. Matter of fact, none of the memory these days is stored in a nice logical setup. So that's why we need other analysis tools. On the Magnet Forensics is a proprietary, right? So this is a paid tool, very common in law enforcement and investigations, DFIR work. There are a couple of free tools that are provided by Magnet. So Dump It essentially forces Windows to crash dump and dumps everything out of the memory. And then the Magnet RAM Capture is essentially does what the FTK imager will do, right? So you can capture what's being held in the memory of a system. So I mentioned that we would talk about common behaviors of malware. And so this helps us in our investigation. So if we kind of think through the purpose of the functionality when malware is introduced into a system. First of all, it wants to run, and that means oftentimes it's a 32-bit program executable. And we'll find that in the processes that are being held in memory. So even if we have what are referred to as fileless malware, it's sort of a misnomer, there's obviously a file, it's just not written down to the hard drive. It's still being held in memory, which means it's recoverable, it's traceable. Malware wants to spread, whether through SMB, right, server message block, through Windows networks, or other lateral movement tools, right? It wants to spread both within the system and outside of that system across the network. Malware wants to hide. It does that through obfuscation. Sometimes it's as simple as a misspelled common system tool, so that the user doesn't see that, explorer.exe is not really the same as explorer.exe, so it's close enough that you skip past it. Malware wants to remain persistent, so it wants to stay on a system. Oftentimes it does that by making registry entries. A common practice in software development is something like a software, think of a software key, it's called a mutex. That information is stored inside of the registry of a system. And so this prevents malware from reinfecting the same system again, which is pretty advanced if you think about that. Now we have malware as a service, ransomware as a service, access as a service. So many criminal organizations operate just like other for-profit software developers at this point. And then lastly, malware wants to communicate. And so oftentimes we have staged malware where it might need to download a new component, or it's looking for instructions or what should I do next. And so there's a fair amount of communication that happens. We hear in ransomware attacks often, right, a C2 command and control. And so we would see that information inside of network connections. So as a reminder, inside of the memory of a running system, you've got the credentials that are being used in that, files, chats, emails, documents, network connections, open port settings, rootkits, hidden processes. You'll find evidence of those in memory, encryption keys, passphrases. One of the things we like to say is that memory does not lie, right? So memory, you can't spoof memory in a system. You can spoof some network traffic. We can obfuscate the IP addresses. We can do those sorts of things inside of the code, but what's being held as memory, is the actual information that the system needs to run that program. So this is something worth keeping in mind. If we talk about developing a methodology, it is very important that you develop a system, an organized system for or a method for conducting your investigation. You need to document each step that you take in your investigation. Um, Oftentimes, old school, a lot of us will have a pen and paper kind of sitting next to us where we're making notes as we're going through. The first step that I recommend, and sort of debated, different entities, different people have different methodologies, but the first step for me is to collect the memory plus any page files. That's the first thing I want to do when I find a running system. And then the second is I want to collect the secondary data for validation. So I want to run tools like or commands like netstat, and I want to run PS list and task list. I want to look at the DNS cache. I want to look at those. I want to save that information off because then I have something to compare it against. Like say, here's what I found in the running Windows system, and here's what was held in memory, and it gives me a way to compare and contrast, if you will. I can kind of validate data within the system. And then the third step is to analyze the memory sample. So when we talk about analyzing magnet forensics, which we use in our forensics training at Northeast Lakeview, you can import memory samples directly into Magnet. We're going to do a little bit more old school. We're going to use Volatility and actually Volatility 3, which is the latest version, to analyze a Windows memory sample that we've captured. It's a suspect system. We're not sure what's happened. And so that's the next project that we're going to go into. Hopefully, you have already set up your Remnix VM. And if you did, you've got Volatility 3 already installed. And I will see you in the next bit.